All right, everybody. So, welcome back to another video. This time talking about inverse trig functions. And what inverse trig functions are, as you may expect based on the name, is they are related to trig functions. So the big thing is trig functions, you may remember from our problems that we just practiced and ones that we've seen a little bit earlier, use angles to help us find side lengths. We need another side length usually, but we're also using an angle. Well, the difference is, inverse trig functions, we're going to be using sides to help us find how big angles are. So it's kind of the opposite idea of what we had before. So, for example, this is a problem that you might have seen before when we were doing regular trig problems, where we would be asked to find the length of segment AC. There's the x representing our variable. And one thing we might know is that this angle here is 30 degrees, and we might know that one of the side lengths is 4. And using that, we'd see that 4 is the opposite side, x is the hypotenuse, and we'd end up using sine to figure out what x was. Well, now that we're dealing with inverse trig, the problems are going to look a little bit different. What you'll notice about these problems where we're trying to use inverse trig is a few things. One, we're no longer trying to find a side length. Instead, we're looking for the measure of an angle. That's one change. Another change is that in order to be able to solve an inverse trig problem, we're going to need to know two side lengths that we have. So in this case, we have the 4 and we have the 8. So those are the big differences between regular trig problems and inverse trig problems. When we're solving these questions, we're still going to use SOHCAHTOA. It's going to be important in helping us solve these. So here's an example of a problem. Let's say that we were asked to find, this M stands for measure, find the measure of angle C. So we want to know how big this theta is. We want to know how many degrees it is. So we're going to start this problem out the same way we start trig problems, which means what we're going to be doing is we're going to have to find out what sides we have for that angle. Well, using the rules that we had, we can see that we have to go across the triangle to get to this side. So we have the opposite side, but also we can see that we have the side across from the right triangle, from the right angle angle. So we have our hypotenuse. So we have opposite and hypotenuse, and we can see that is we're going to be using SO, which means we're going to be using sine. So remember that the way we're going to set sine problems up is we have sine of theta equals the opposite side over the hypotenuse. And in this case, we don't know what theta is. So we're going to have sine of theta, and theta is what we're going to solve for, equals, we know that our opposite side has a length of 7, and that our hypotenuse has a length of 18. So we have sine of theta equals 7 over 18. Now, at this point, you're probably wondering, how do we get theta by itself? Well, the answer to that is we're going to use the inverse of sine. And there's actually a button on your calculator that does that. Inverse of sine on your calculator is most likely going to look like what I'm about to write in green. It's going to be sine with a -1 in the upper right-hand corner. So what we're going to do is we're going to take the inverse sine of both sides. So the way this is going to work then is inverse sine over here and sine are going to cancel each other out, leaving us with theta. And this part over here, sine negative as the inverse sine of 7 over 18, we're going to have to enter that into the calculator. Here's my recommended way of doing it. What I would recommend doing is I would enter in the 7 over 18 first. So I get 7 divided by 18 equals you're going to get a decimal. Now, most calculators are equipped where what you're going to have to do is get the inverse sign, and you're usually going to do that by hitting second, then sign. We'll wrap around these numbers on some calculators. Other ones you've got to do it in a different order. But your goal is to get the inverse sign of 17 divided by 18, which is 0.18. And once you have that, you can answer. Make sure your calculator is in degrees. You get about 22.89. And that would be our answer for that one. That's how many degrees this angle is. Right there. So 22.89. All right, one more example, and then I'll give one for you to try on your own. Measure of angle B in this situation. Well, here's our angle. Right there. What sides do we have? One of them is the opposite side, and the other one is the adjacent side. Right next to the angle, but not the hypotenuse. So we have O and A, which means we're going to use. So, setting that up, we're going to have tangent of theta. We don't know the angle yet. Equals. Tangent is opposite over adjacent. So our opposite side was 3, and our adjacent was 4. Then just like the last problem, to get theta by itself, we're going to do the inverse of tangent on both sides. So it's the inverse tangent of 3/4, which is 0.75. So I could just hit second tangent. I need to clear the calculator first, so let me do that. So I could just hit second tangent and then put in 0.75 because 0.75 is 3/4. Close the parentheses, hit enter, and there's my angle measure. It's about 36.87. So theta is 36.87 degrees. So really, the biggest part about this is knowing how to enter it into your calculator. You need to know what the sides are, opposite, adjacent, hypotenuse, and then how to enter this into the calculator. Those are the big things here. So I'm going to leave this one for you to try on your own. Bring it to class coming up for when we talk about this, and then that's it. That's really all I'll have in the video. So here's the problem. Best of luck to you, and I will see you again in class.